Alright, this is a lesson on rational equations, and so we'll take a look at one that's a little bit easier first, and then we'll move into some that are a little bit harder. So in this particular problem we have a minus 5 minus a over 4, and due to the fact that a is the only thing we have in the denominator, and it's only right there, we need to have a in all of the other denominators. So I'm going to multiply the first one by a over a, and I'm going to multiply the second one by a over a. And for the time being, we don't really need to worry about the denominators. So what I have here is a times a is a squared minus 5 equals 4a. Now in order to solve this, we need to get 0 on one side. So I'm going to subtract 4a on both sides. And we got a squared minus 4a minus 5 equals 0. Now we can solve this particular equation by either doing factoring or the quadratic formula. Because factoring is easier, the only way we can break this down is a times a and 5 times 1. And one of them has to be negative and one of them has to be positive. And so since negative 5 plus 1 equals negative 4, I have the correct factors. We said a minus 5 equal to 0, and a plus 1 equal to 0. Add 5 to both sides, so a equals 5. Subtract 1 to both, a equals negative 1. Now if I plug both of these back into the original equation, if I plug 5 back in right here, we don't have 0 on the bottom. If I plug negative 1 in here, I don't have 0 on the bottom. And so both of these answers are okay. So let's try another one. 9 over b plus 5 equals 3 over b minus 3. Well, this one is similar to a problem that you've done already, where you would tell me that I should cross multiply. And that makes sense. So when I distribute, we get 9b minus 27 equals 3b plus 15. Subtract 3b on both sides. And I may as well add 27 to both sides, so that these can cancel and these can cancel, and so we get 6b equals 42. Divide both sides by 6. B equals 7. We put it in here and in here, and since neither denominator is going to be equal to 0, we're okay. So we got t plus 4 over t plus 3 over t minus 4 equals negative 16 over t squared minus 4t. So for this particular problem, what I'm first going to do is I'm going to factor this part over here, which factors has a common of t. So what do we need in each of these first two in order to? Well, this has a t, but the first one has a t, but not a t minus 4, so I'm going to multiply by t minus 4 over t minus 4. The second one is missing a t. And the third one has both t and t minus 4, so we have this all set up. And since all of these t's and t minus 4's are on the bottom, we're going to cancel them. And I'm going to put parentheses around the t plus 4 so that we know we need to multiply those two together. When I multiply t plus 4 times t minus 4, I got t squared minus 16, plus 3 times t is 3t equals negative 16. In order to solve this, I'm going to add 16 to both sides. So I got t squared plus 3t equals 0. Once again, I'm going to solve by factoring. In this case, both of my terms have a t, so I'm going to factor this out. So I have t equals 0, or t plus 3 equals 0. Subtract 3 on both sides, and t equals negative 3. When I plug t equals 0 back into the first t right here, we wind up having 0 on the bottom, and that won't work. When I plug t equals negative 3 in, both into this one up here, and the first one and the second one, we get negative 3 or negative 7 on the bottom for these two. And even if I plug in the second one, it'll be 21. So we don't have 0 on the bottom. So t equals negative 3 is a legitimate answer. Alright, we will do this final one where we have 2 over y minus 1 equals 6 over y minus 1. Well, in the first one, we don't have anything to factor. So in the first term, we're missing y minus 1 over y minus 1. In the second one, we're missing y and y minus 1. So I include them both. And the last one, I'm simply missing y. So now we have all of these y's and y minus 1's. For all of them, I'm going to cancel. So 2y minus 2 when I distribute, minus y squared plus 1y, because I'm distributing negative 1y into this parenthesis, equals 6y. So I have negative y squared, 2y plus 1y equals 3y, minus 2 equals 6y. Subtract 6y on both sides, and we got negative y squared minus 3y minus 2 equals 0. To make this easier to factor, I'm going to multiply both sides by negative 1. So what two numbers multiply up to be 2 and add up to be 3? Well, we don't have a whole lot of choices here if we're going to factor. So we get y plus 2 times y plus 1. So when we have y plus 2 equals 0, y equals negative 2. And when we have y plus 1 equals 0, we get y equals negative 1. Both of these, when I plug them back in, will work, because when we plug negative 2 in, we get negative 2 and negative 3. And when I plug in negative 1, I get negative 1 and negative 2. So there is our rational equations. And let me know, email me any questions or message me any concerns. Thank you.